Alright, now what we're going to do is look at 1.10, which is precision and accuracy. It's sometimes referred to as maximum and minimum values. And as you can see from the new vocabulary, there's quite a bit, but we're more interested in the precision and absolute errors. Okay, precision means that how close it is or how near it needs to be, and that is determined by whether it's whole numbers, whether it's decimal places. Okay, so on the example below, what you've got is it's giving you it's 6.4. So you know that you go into the nearest tenth, okay? Well, what you do is you go halfway then into the hundredths, okay? So you add and subtract 1/100th of each. So your answer is going to be 6.4 plus or minus 0.05. In other words, it's going to be 6.35 or 6.45. That's going to be the maximum or the minimum, okay? And again, quarter inches, the next one's a quarter inch, so half of a quarter of an inch is an eighth of an inch. So in imperial or American standard, it's going to be every eighth. So you're going to be doing whatever the question is, it's 2 1/4 inches plus 1/8, or 2 1/4 inches subtract an eighth. So let's do a couple of these to make sure we've got it okay. All right. Well, we're looking at eighths, okay? So question number 1, we're looking at eighths. So if we do whatever half of 1/8 is, you're going to finish up with a 16th, okay? So that's going to be a 16th. So you're going to do 2 1/8 plus or minus 1/16, okay? So so what you're going to do there is you're going to have 2 1/16. And it's going to go all the way to 2 3/16. So there's your minimum, and that's your maximum. So if I were this, so that's question number 1. So let's have a look at question number 2. This time we're in hundreds, so you've got to go to thousands. So this time it's going to be 4.81 plus or minus 0.005. Okay, so it's going to be 4.805 or 4.815, maximum, minimum. Okay, so in example 2, what we're doing now is going back to significant figures. And then don't forget, when you use significant figures, you always start from left to right and start at the first non-zero. So if you look at A, it's telling you that every number, well, it's greater than 1, so every digit is significant. This is 6 significant figures. Okay, if you start at the B, which is 0.007, okay, the first 0 is 7. Okay, so you don't count the 0.00, so you start at the 7, and it's 750, so you count all 3 of those, so that's 3 significant figures. So let's have a look at example 2 in question. So this is number 4. Remember, you start from left to right and you start at the first non-zero. Well, the first non-zero is the 5. So you count every number from the 5. So that's 5, 0 and 3. So question number 4, you have got 3. Question number 5, you start at the first non-zero from the left. So the 9 is the first non-zero. Then you count every other number. So the 9, the 5, the 2 zeros and a 1, so number 5 is 5. And same with number 6. Okay, we start from the left to right, 7 starts it off, and the 0 after the 5 is the last one, so that's also 5. So let's have a look at example 3s for accuracy and relative error. Okay, you've got a key concept. This is the absolute error. In other words, what degree of accuracy is it, the absolute values again, over the expected measurement. Well, you've got 23, it tells you to be 23 centimetres. It's a whole number, so your maximum and minimum or your precision is going to be 0.5. It's half the distance. Remember, they're whole numbers, so it's 0.5. That's why you get 0.5 over 23. put that in your calculator and change it to a decimal, which is 0.022, multiply that by 100, so there is an error measurement of 2.2%. A lot of people will use this information when they're doing different types of statistics and things like that. Okay, so let's go back to what we did. So don't forget, your relative error is going to be whatever is the absolute error. So I'm just going to write absolute error over the expected, or the measure. Remember that was from that key part. So if we work on that, the absolute value, so this is 1 foot and half of 1, so it's a whole number, so that's 1, so it's going to be 0.5, which is going to go over the 1 foot, and we know that's going to be 0.5, and that's going to be 50%. Okay, so it's the absolute value error over the measurement.